Hello, welcome back to Math with Patrick. It's March 18th. We have problem number 77 from the Daily Epsilon calendar. And guess what? We're going to figure out why the answer is 18 today. So we are finding the count of base 3 three-digit numbers. Okay, so find the count. This just means like how many. Base 3, let's talk about that in a sec. But three-digit numbers, that's going to just look like 100 to like 999. And so if we were asked find the count of three-digit numbers, well, it would be all the numbers between 100 and 999. If you want to count the amount of numbers between two numbers, you subtract them, but then add one. If you want to include both, that is like if we want all the numbers between 5 and 8, there's 5, 6, 7, and 8. So there's four numbers, but if you just do the subtraction, you're only going to get the number 3. So if you want to figure out all the numbers between two bookends, just make sure to add 1 at the very, very end to actually get the real count of all the numbers. So anyways, we're going to have 999 minus 100 equals 899, but then add the 1. So if we were doing this with base 10 numbers, we have 900 three-digit numbers. However, this is in base 3. That felt a little big. 900 three-digit numbers? I guess that makes sense. I counted them all. I'm just kind of surprised that in base 3, we're going to have so much fewer. We're only going to have 18 of them. So let's figure out why. What's base 3? Base 3 is a counting system where you only have 3 digits. And the best way to think about it is just you have 0, 1, and 2. But the number 3, this symbol, just doesn't exist. Kind of like how in our base 10 counting system, once you get to the number 10, we don't have like a new symbol for it. We have to use some of our older symbols and start introducing place value. So that happens with base 3 counting as well. We still have 0, we still have 1, we still have 2, but then to express this idea of 3 objects, I don't have the number 3. I have to start introducing place value already. So this is equal to the number 3. Maybe to denote what base I'm working in, I could use the subscript of 3. So 10, the number that looks like 10 in base 3, is the number 3 that you and I know really well in base 10. Kind of weird. All right, let's keep counting. The next number after 10 is 11. I can use it because, well, I have the digits 1 and 1. Again, this is in base 3. Just to keep your mind on track, this is just the number 4 that you and I know. I can keep counting. I have the digit 2. I can go 12. This is again in base 3. This is the number 5. And then here's the issue. The next number after 12 is 13. I can't use the symbol 3. That doesn't exist in base 3. So the next number that I could even think to write would be 20. And this is the number 6. So here's how you can read a number quickly in base 3. This first value counts how many 1s you have. So how many 1s? This second number counts how many 3s you have. And then by the time we come around to the hundreds place, well, guess what? That's not actually the hundreds place anymore. That's the nines place. It's 3 squared. And then the thousands place, again, isn't the thousands place. This will be 3 times 3 times 3, or the 27s place. So how do we count how many 3-digit numbers we have? Let's think about it. So the first one is going to be 100, because previously, let's start counting up here. Previously, we're going to have 2, 2, so what looks like 22. But again, this says we have 2 3s and 2 1s. So that's going to be the same thing as just the number 8 that you and I know. So I guess with my dots, I just skipped the number 7. Oh well. But then after that, I don't have the digit 3. So I must introduce the next place value, my 9's place. So what looks like a 100 in base 3 just means 9 objects. And this is going to be our first 3-digit number. And, well, let's see. the answer is 18, like today's date is the 18th. Do I really want to list out all 18 of those numbers? I mean, why not? If I go fast, it shouldn't take too long. So let's count really quickly. We have 101, 102, and then I need to hop over to the next place value. Then I count 1, 2, then I need to hop over to the next place value. Then we go 1, 2, and then I need to hop over to the next place value. But wait, 3 doesn't exist in this system, so I need to hop that over to the next place value again. And so now I get to the number which, well, what looks like 200, but again, you can count how many 1s, 3s, and 9s you have. So this is just the number 18. Okay, so I feel like at this point, I could kind of extrapolate a little bit. So here we can count how many 3-digit numbers that start with 1. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can kind of see that the next chunk will also have 9 in them. So I can just kind of go dot, 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 and there should be 9 here as well. Because once I get down to the number 222, well, if I try ticking this up to a 3, again, I can't because I don't have that digit. And all of these numbers spill over, kind of like after the number 999, we get to 1000. So after 222, we're going to get what looks like 1000 in base 3. And that is now a 4-digit number. So here are all 18 of my 3-digit base 3 numbers. All right, there they are. Guess we're all done. Thanks for exploring base 3 with me, and I guess I'll see you tomorrow for the next video. All right, bye.